Welcome. In this lectures, we will talk about significant figures and their rules. The term significant figures refer to the digits that was measured. Why we pay attention to significant figures? Because we don't want to overstate the accuracy of the measurement. For example, in the lab, if you want to weigh a sample of chemical, you're gonna need to use something we call a weight boat. So you weigh the weight boat first. Its weight is 0.6519 gram. You put the sample in the weight boat, you weigh them together, 3.22 gram, right? You subtract the two numbers, the mass of the sample is 2.568100. Okay, this is the calculate value. However, would it be accurate if we report these numbers as the mass of the sample? The answer is no, because these numbers you have 6 decimal place, but none of these numbers have 6 decimal place. That's where significant figures come in, and they have several rules that you have to pay attention to. The first rules: all non-zero digits 1 to 9 are significant figure. For example, 3.25, 1, 2, 3, 3 significant figure. 1896, 1, 2, 3, 4, 4 significant figure. When it comes to zero, now zero is a little bit tricky. If you have zero between two significant figure, then that zero you will be count a significant figure. For example, 3.005. These numbers will have 1, 2, 3, 4. 4 significant figure. 106. 0 is between 1 and 6. 1, 2, 3. 3 significant figure. 20,002. You have 30 between two numbers of 2. So 1, 2, 3, 4, 5. 5 significant figures. Now, if you have 0 at the beginning of a numbers, then the 0 are not significant figure. We call them placeholder. For example, 0.0057. The first 30 will not be count a significant figure. You only count 5 and 7. So these numbers had two significant figure. 0.292. This 0 are not significant figure. 2, 9, and 2 will be your significant figures, and 3 significant. 0.00008. The first zeros are non-significant figure. Only 8 is significant figure, so 1 significant figure. 0, how about 0 at the end? If you have 0 at the end, then the 0 as significant figure if and only if a decimal point is written in the number. For example, 8,000. Okay, the 0 at the end are not significant figure. Only 8, the first numbers, so this one significant figure. However, if you put a decimal point after the last 0, now these numbers has 4 significant figure. 2.3900 have 5 significant figures. Okay, 1, 2, 3, 4, 5. However, 239, these numbers will have 3 significant figure. Now, you might say, wait, 239 and 2.3900 are the same as long as 8,000, 830, and 830 decimal point. There is a different, okay, from a scientific point of view. Okay, so 2.39 and 2.3900. Now, these numbers right here, you only son, it has three significant figure, 2, 3, and 9. After 9, it can be 0, it can be 1, it can be whatever number it is. But the second number, 2, 3, 9, 0, 0. When you put 20 after the number 9, you tell the readers that, okay, I am son. After number 9, there are two zeros number, right? Because there is a rules in scientific field, okay? If you are not sure about anything, do not report, okay? If the data does not make sense, do not report. Because the moment you report the doesn't make any sense, doesn't make sense data, people will start to ask question. And if you're not ready with the answer, then there will be a problems, right? So in short, 0 at the end, the purpose is tell the readers, okay, at that position, that numbers is 0, right? That is certainty. If you don't put it like in the first case here, then you are uncertain what digit might be after number 9. Now, add and subtract. When you add and subtract, then the answers must contain the same numbers of the decimal place as the measurements with the fewest numbers of decimal place. Now, keep in mind, now at this point, I say decimal place, not significant figure, okay? So, have it here. 106.7, 1 decimal place. 0.25, 2 decimal place. 0.195, 3 decimal place. You add these three numbers together, you put in your calculator, you will have 107.145 gram. Now, because you perform addition, you had to round your answer to the fewest numbers of decimal place. Fewest here have one decimal place, so your answers had to be 107.1 gram. That is adding and subtraction. Now, when you dealing with the unit, okay, we treat the unit the same way we treat x in algebra. 1x plus 2x equal 2x. Okay, then 1 gram plus 2 gram equal 3 gram. Okay. Multiply and division is a little bit confusing because when you multiply or divide, then the answers must contain the same numbers of significant figures as the measurement with the fewest numbers of significant figures. Okay, adding or subtraction, you follow the decimal place. Multiply and division, you follow the numbers of significant figure. For example, here, 7.3, two significant figure, time 0.002, one significant figure. The first three zero are not significant figures, they are placeholder. You put the two numbers in your calculator, you're gonna have this number 0.014600. You round your answer to the fewest numbers of significant figure. So in this case, choose reports with one significant figure, 0.0, then we stop right here. So the final answers of this math is 0.01 centimeter square. We treat unit the same way we treat x. So 1x times 2x equal to x squared. Then 1 centimeter times 3 centimeters equal 3 centimeter square. Right? So that's how significant figures rules is applied. But now, last few things. So when you perform calculation, do not round early. And I cannot stress this enough. Why? Because this will affect the accuracy of your answer. Always round your answers when you are at the end of your calculation. This rule number 7 here will be important when we talk about dimensional analysis and stoichiometry. The order of the math equation or the math function is important. That means, or PEDMAS. What does this mean? That means when you do perform addition, division, or multiplication or subtraction, what's in parentheses you do first? Parentheses first, then exponential, then division, then multiply, then add, then subtract. Okay, that's what PMAS stands for. So P mean parentheses. E mean exponential. D division. M multiply. A addition. And S subtraction. Now, last but not least, exact numbers should not be used to determine significant figure. Okay. For example, if you remember the quadratic formulas, okay, minus b plus or minus square root of 4ac. Okay. So in this case, this number 4, this number 1, 2, 1. These are exact numbers. Okay, exact numbers should not be used to determine significant figure. So in this case, even though you have 4 numbers that have for one significant figures, is the not involved. So the fewest significant figures in this case is 3. So that's why your answer is 3.76 or 0.68. Right. Now, the first one, right? Here's the examples of PEDMAS, okay? Parentheses, you do first. Then you do exponential. Then you will add the two values together to arrive at the final answer. And 9 have the fewest decimal place, so that's why your answers will round it to 1 decimal place. That is for significant figure. Okay, to summarize, the take-home message from this lecture is significant figures. Know the rule. What is count a significant figures? What is not? Pay attention when it comes to 0. Does the 0 have the decimal place at the end? Or is it a placeholder? Okay, do not round early. Make sure you pay attention to the orders of the equation. And last but not least, exact numbers should not be used to determine significant figure. I will see you in the next